we're going to look at the number of 110. So do you have this? Example 1. Well, they have 1/10 there, but they don't have this picture for you. So maybe I'll move a little bit ahead here. And this you have at the bottom of page 65. And this at the top of page 66. So the idea is, if you take any r value between -1 and 1, and you look at its geometric sequence. So if I picked, I like r is 1/2. And I'm going to do a demonstration of this, where I'm going to start off with term 1 being 16. No, 16 is too much. I'll start off with 8. Term 1 is 8. And then if r is 1/2, would you agree that term 2 would be 4? And term 3 would be 2. And term 4 would be 1. And then 1/2. And we're going to do this forever. And because the r is less than 1, or between -1 and 1, as a fraction between -1 and 1, if we do this forever, it'll eventually get to very small. I can demonstrate this by starting 16 squares away from the wall. Got to shut the door here so I can actually get you to visualize this. Got to count up correctly. 1, 2, 6, 8, 10, 16. Okay, perfect. I'm exactly 16 squares away from the wall, and I'm going to follow the following rule. However far away from the wall I am, I'm going to walk half the distance. Would you agree the first time I would walk 8, just like I have shown in this sequence, I'd walk 8. I'd get to 8 squares away from the wall. There we go. I'm 8 away. Then I would walk 4. No, I might not have been 8. Now I'm 4 away from the wall. Then I would walk 2. And every time I'm getting half closer to the wall, because now I'm 1 away, and next I have to walk a half. And then a quarter. And then 8. And then 16. Will I ever get to the wall? No.
You'll get infinitely close.
I will get infinitely close to the wall. But you guys, bell will go, you'll go home, you'll come the next day, and I'm like, and I just get closer and closer and closer. And so close to the wall that eventually one of you will be nice and say, okay, Mr. Jerry, you can stop. We see you're very close to the wall. And the idea is, if you would keep on going forever, you would be so close to the wall that we would basically say you are at the wall. And so what we're going to say is that this infinite sum adds up to 16. It never gets to 16, but it gets so close to 16, it's basically 15.9 repeated. And you'll be like, hey, wait a minute. That's basically 16 too. So how does that work? Well, if we take our normal sum formula for this sequence, our term 1 is 8. Then we had 1 minus r, which is a half, to the n, over 1 minus a half. And we could actually figure out, if I did this for 3 days straight and cut it in half 10,000 times, we could plug it into the formula. I don't know. Maybe 10,000 would be too much for the calculator even to calculate. But we're going to try. We're going to say I've got 8, and then it was 1 minus 0.5 to the power, how many times did I say? 10,000? Oops. Okay. The calculator might run out of decimal places. It might already tell me I should have stopped. You're already at 16. We're going to find out. Divided by 1 minus r, which is 0.5. Push enter. You're already there. The calculator has so many zeros, it's not even going to show us that you weren't quite there. Let's see if I do the same thing, but we only do 1,000 times. I'll delete 1 0. Still too close to 16. Okay, let's say I do it only 100 times. No. Even at 100 times, it's like so close. Let's go back to 10 times. Maybe I would get tired after 10 times. Oh my goodness. There. Oh. At 10 times, I would have been at 15.98. That's very, very close. If each of these squares, if you think about what 0.02 of a square is, I'm basically at the wall after 10 times. If I continued it from there another 10,000 times, that's insane. Why does that happen? Because this part, that 1/2 to 10, is very close to 0. If you do 1/2 to 100, your calculator will already be like, it's so close to 0, I'll just go with 0. Your calculator can only hold so many decimal places. Computers can only hold so many decimal places. They have limits. And if you made the first 800 million decimal places a 0, and then followed it by a 3 and a 7, your calculator can't hold that many numbers. So it's just going to count, oh, maybe it can hold 32. Maybe it can hold 64. Most calculators show you 8 and hold another 8 or another 24 for a total of 64 total, or a total of 128 total. They don't hold that much. And if they were all zeros, they'll say this goes to 0. Which makes our formula quite beautiful. Look, if I simplify and say, oh, that's just 0, then I'd be left with just 8 on top. 1 minus 1/2 is 1/2. How do you divide by a fraction? You multiply by the reciprocal, and you get 16. Did you get it close? Oh, it goes in this. And our formula that was, remember this was our complicated formula? If you go to infinity, and the r is between -1 and 1, this part just becomes 0, and you get a really beautiful, simpler formula. Today you're going to learn that it's easier to add up an infinite amount of numbers than it is to add up 10 numbers. That seems weird, but the formula is easier. And this formula is on your formula sheet as well. But it only works if your r value is between -1 and 1. In other words, sometimes this is written this way. The absolute value of r is less than 1. Because whether it's positive or negative, the fraction itself has to be a fraction less than 1. Because if it's less than 1 and you multiply it a ton of times, it'll eventually get close to 0. So we can go to our second example here.
Question.
Yes.
You said it could be less than 1, but
Yeah.
Could it be 0.9 repeated?
No, because 0.9 repeated is equal to 1. So it says less than 1, but it's not equal to 1. And 0.9 repeated is the same as 1, so you couldn't have 0.9 repeated either. So here's our first question. For these, we have to figure out what our R value is. And if it works, we're going to find the sum. Can you see in the first one that you're dividing each number by 4? Dividing by 4 is the same as multiplying by a quarter. So this one will converge. And we can use the formula then and say term 1 was 32 over 1 minus r. This would give us 32 divided by, right, 1 is 4 over 4 minus 1 over 4 would be 3/4. Dividing by a fraction is the same as multiplying by the reciprocal. And so we get 128 over 3 as an answer, which, if you'd rather have a decimal, this will be 42.6 repeated. Adding up the first couple, does it look like we're still going to be under 42.6? Right, here I'd be at 40, 42, 42.5. Looks like I'm going to be under 42.6 repeated. If you added up one more, you would already be at 42.625. That's pretty close after adding up only 5. For part B, if something is changing, positive, negative, that's telling your R value is going to be negative. And it looks like we're dividing by 10, so that would make our R value 1/10. Oh, I think we did this one already, but maybe starting at a different number. So, if we add this up to infinity, our term 1 was 100 over 1 minus a negative 1/10. That would be 100 over 10 over 10 plus 1 over 10, 11 over 10, multiplied by the reciprocal. Which, if you like decimals, I believe is 9.90 repeated. Yes. Questions to circle for this one? Are 5, 6, 7, and 10.